Bismillahirrahmanirrahim. My name is Abdul Kareem and roll number is 84037. My seminar topic is immunoglobulins. Immunoglobulins are known as antibodies. These are glycoproteins produced by the plasma cells. Act as a critical part of immune system. They recognize and binding to the antigen and destroy it. These synthesized are secreted by the B lymphocytes found in the serum and some tissue fluids. 20% of plasma proteins is consist on immunoglobulins. Structure: it composed of one or more units, each containing 4 polypeptide chain, 2 identical heavy chains, and 2 identical light chains. The amino terminal of each polypeptide chain show considerable variation in amino acid composition. L chain consists one variable domain and one constant domain. H chain, heavy chain, consists one variable domain and 3 constant domains. These are the structure of antibody. 2 units FAB and FC. FAB is the fragment antigen binding, where the antigen is binding, and the FC fragment crystallized. CL is the constant domain light chain and CH is constant domain heavy chain. These shows blue is light chains and yellow is heavy chains. These also shows the oligosaccharide which are attached in a constant region or FC region. Heavy chain domain function, effector function, and while the variable domains of antibody consist antigen specific. The H chain consist domain is generally defined as C1, C2, or C3, which are present in 3 types of amino antibodies: IgG, IgA, IgD, and additional domains CH4 for the IgM and Ig. The CH located in within the FAB region, and remaining domains are present in FC region. This FC defines isotype, subclasses of immunoglobulins, affinity and kinetics of binding of antibody, influence the antigen recognizing and binding. This is the structure where shows that the constant heavy and light chains attach each other by disulfide bridges and so on. Role of glycosylation. Glycan associated especially with the FC domain show the affect antibody function. Glycosylation is varied by the isotypes. For example, IgM, the N-linked glycosylation site located is ASN 293 is the amino acids which are glycosylation on CH2 domain, and many as 32 possible glycosylation pattern which interact the hydrophobic pocket and stabilize the immunoglobulin structure. If the IgM cannot mutate, sequence is muted and glycosylation is limited, then its affinity or function is disturbed and it cannot bind to its receptors. This and glycosylation is suggested after the translation, it is post translation modification. This is a glycoside pattern in different antibodies. Classes. There are five main classes: IgG, IgM, IgA, IgD, IgE, and these distinction by the heavy chain found in molecules. IgM have the gamma chain, IgM is IgG has the gamma chain, IgM has the mu chain, and IgA has alpha, and IgE is epsilon, and IgD is delta chain. Firstly, we discuss immunoglobulin G. IgG is a monomeric. It consists one unit. Molecular weight is 146 kilodalton. In the serum concentration 9.0 mg per ml. Synthesized mostly in secondary immune system. Classical pathway of complementary system, highly protective, and the four subclasses IgG1, IgG2, IgG3, and IgG4. It's also cross the placental barrier and enter in the fetus and protect it from the infectious disease. This is the structure of IgG. Properties of IgG. Heavy chain is gamma, and it's 5,3 plus present total immunoglobulin 75%. Glycosylation by weight 3%. Distribution intra and extravascular. Role of IgM in immune system. Major immunoglobulin in blood, lympholoids, cerebral fluids, palatine. 15% total proteins present in, and it provides the fetus for the protection. React with Fc gamma lambda receptors present on the surface of macrophage and neutrophils and natural killer cells, and it activates the complement system of a body. Critical step in opsonization and phagocytosis. It delayed response of a infection. We discuss secondary immune response, but it retain in the body long time. These for this property we use in vaccination. Ig is principally antibodies used in immunoglobulin research and clinical diagnostics. Ig subclasses. Subclasses different from the disulfide bridges, length and flexibility of the Hunt region. Variable region within one class share about the 90% of homology and 60% among the classes. IgG1 60 to 50% total main subclasses IgG. Thomas mediate immune response against the proteins and the polysaccharide antigen. Bind to the Fc receptor of the phagocyte cells, and deficiency is of these antibodies cause hypogammaglobulinemia. Ig2 second largest of IgG isotope, 20 to 25% main subclasses. Its response against the carbohydrates, polysaccharides, antigens. Deficiency is most common, associated with the airways receptor infection in the infectant. IgG3 5 to 10% total IgG. Major role in immune response against the protein and polypeptide antigen. Affinity of IgGs can be higher than that of IgG1. Less than IgG4. Less than 4% total immune. Does not bind to the polysaccharides. Serum level of in patient with suffering with certain diseases just like intestinal pneumonia. Price's total role of IgM is still as unknown. Immunoglobulins M. It's a pentameric structure. Molecular weight is 970 kilodalton. Serum concentration is 1.5 IgM per ml. Produced by the primary immune response to the antigen. This is a structure shows the pentameric structure of the IgM, and these 5 units joined by the joining chain. The heavy chain is mu, type is mu, and serum concentration is 5.5 to 2 ml. Percentage present total immunoglobulin 10%. Glycosylation by weight is 12%. Distribution mostly intravascular. Function is primary response. Role of IgM in immune. First, the antibody built during the immune response, and is pentameric structure due to pentameric 10 free antibody sites, highly added, and its valence is 5. It's attached 5 antigen, one in on one antibody. Not versatile as a IgG. Vital role in complementary activation and agglutation. Found in the lymph fluids and blood. A very effective neutralizing agent in early stage of diseases. And its elevate the levels is a sign of recent infection or exposure to the antigen. Now, IgA molecular weight is 320 kilodalton in secretory form. Heavy chain type is alpha. Serum concentration is 1 to 4 mg per ml. Percentage of total immunoglobulin 15%. Glycosylation by weight is 10%. Distribution intravascular and secretions. Function protect mucous membranes. This is the immunoglobulins are bimeric, which are two composed of 2 units, and these units joined by the joining chain. Subclasses of IgA is Ig1. 80% of total IgA concentration in serum. Broad resistance against the several proteases, but the some affect and splice the Hunt region. Good immune response to protein antigen, and lesser degree in polysaccharides and lipopolysaccharides. IgA2. Up to 15% total IgA in serum plays a crucial role in mucus of the airways, eyes, gastrointestinal tract, fight against the polysaccharides and lipopolysaccharides. Good resistance to the proteases, many bacterial proteases. Due to this property, importance is fighting against the bacterial infection. Role of IgM in response. In serum, mainly monomeric, but in secretion such as saliva, tears, mucus, sweat, is dimeric, two units combined, mostly present in secretory form and preventing invading pathogens by attacking and preventing the epithelial surface. Very weak complementary activating antibody, not induce the bacterial cell lysis via the complementary system. Its work with the lysozymes hydrolyze carbohydrates in bacterial cell wall, pendulum form in epithelial surface, which act as a neutralizing antibody. Now, IgE is a monomeric. Molecular weight is 1 every 8 kilodalton. Serum concentration is 0.005 mg per ml. Protects against the parasites, binding to high affinity to receptors of the mast and basophils causing allergic agent. This is the structures and also show the glycosylation in IgE. H chain, heavy chain is epsilon. Serum concentrations 10 to 400 nanogram per m. Percentage of total immunoglobulins 0.002%. Glycosylation by weight is 12%. Distribution basophils, mast cells in saliva and nasal secretions. Protect against the parasites. Role of IgE in allergic reaction. Antigen bind to the Fv portion, degranulates and release the factor like heparin, histamine, which induce the allergic reactions. Vascular dilation, increase the small vessel permeability. These are the symptoms of allergic reactions. And some allergic diseases just such like asthma and some parasite infection tapeworm lead to increase the IgE level in blood serum. Binding of the eosinophils with the Fc receptor of the Ig located parasitic worm is resulted in death of parasites. Low level of IgEs can occur in a rare inherited diseases and that affect the muscles coordinations. Now, immunoglobulins D is a monomeric. Molecular weight is 184 kilodalton, present in the major amount in serum 0.03 mg per m. Regret as a BCR. Plays a very essential role in antigen triggering lymphocyte differentiation. This is the structure of the IgD. Molecular weight is 180 kilodalton and the H heavy chain type is delta. Serum concentration is 0.4 mg per ml. Percentage of total immunoglobulin is 0.2%. Glycosylation by weight is 13%. Distribution lymphocyte surface and function is still unknown. This is the mechanism of antibodies production. This is a 5 steps when the attack of antigen. Firstly, antigen recognition. Immune concept B cells exposed to the antigen and antigen bind only to the B cell with the complementary receptors. The B cells also have the antibodies which are embedded in their membranes. Then the antigens person- presentation. The helper T cells attach to the epitope, and this is the activation of B cell, B lymphocytes, and attachment of the T helper lymphocyte. This red dot shows the epitope and the antigen. When they attach, uh, T cells attach to the B cells on the epitope, then it release release the hormones such as intrakinase. Then it induce the cloning selection. It's some differentiate rapidly, and some cells uh, convert in plasma cells, and some memory cells is called the differentiation. Then the plasma cell produce the antibodies and attack to the antigen and harmless. And the memory cells is present long time in the blood, and which are our security for future. Clinical signification. Role of in protection against the bacteria, virus, fungi, and if the deficiency in infection diseases, X-linked transist hypoglossal infectant, IgM differentiate. These are the diseases which are very common in deficiency of immunoglobulin. Just IgM antibodies is tetanus, toxid, hydrotoxis, toxides, and polio, which are very helpful in post immunization in vaccination. Elevate the quality of immune response after the vaccination. IgM antibody reports exposure. Measles, varicella zoster is in this test we elevate the production of antibody against the antigen after the infection disease has occurred. Detection of IgM, anti-type A blood, anti-type B blood. In response of bacterial antigen present in the digestive tract, and there is literally is view 1% 1:4 in antibody deficient disorders. Other assay test of heterophils antibodies measure of presence of antibodies against the Aspergillus virus, serum proteins, electrophoresis, which are used to clinical use of immunoglobulins. Immunotherapies. We use the immunoglobulins in immunotherapy like drugs. Purified immunoglobulins is treatment of many immunoglobulins problem, including antibody deficiency, and we also use in severe combined immunodeficiency disorder, multiple sclerosis, and some other diseases. And we also use immunoglobulins in organ transplantation. Thank you. This is the reference. Thank you.